On page 81. So they want us to find the point of estimate. So the point of estimate is going to be halfway between 135 and 165. So the number that's halfway between those is 150. Hey. So that's our point of estimate, 150. Okay, 15 above, 15 below. And then what does it mean? This is where we think that's an I. The mean is. In just layman's terms, it's not exact reason, but it's close enough. All right, excuse me. Find the margin of error. Margin of error is plus or minus 15. All right, it already dorked up on me. So margin of error is plus or minus 15. So what we would say in that is, because they're doing a 95% confidence interval, that we are 95% confident that if we redid this, if we redid our study with 100 baseball games, that our baseball games would fall between the time limit of 135 and 165. Good to see you. Okay. And then interpret the confidence interval in the context. So we are 95% confident that we collect random. Again, our data will fall between 135 and 165, and that has to deal with minutes of the length of a game. And then, is the researcher sets the confidence interval to 90% instead of 95%, what's going to take place? So if I set my confidence interval lower, my numbers come in. Hello? One more time. 1, 2, 3. There we go. So 95% wider region, 90% a little more narrow. Okay? And then the baseball fan claimed that baseball games now average more than 2 hours. Is there evidence? So 2 hours is 120 minutes. The confidence interval is 135 minutes, 165 minutes. So yes, that is a good claim, because our entire confidence interval is above the 120 minutes, which is 2 hours. Shh. All right. Down below, it says, assume a business owner is trying to determine the average time a customer spends in his store. He randomly samples 200 customers, produces 80% confidence interval between 9.4 and 13.6. Those are time in minutes in the store. Interpret the confidence interval. So the business owner is 80% confident that if we sampled another 200 customers, that they will fall between being in the store for 9.4 to 13.6 minutes. Number 7, 80% is considered a fairly low level of confidence. What is the advantage of using a lower confidence or lower confidence level? So our confidence interval will be smaller. So the lower the percent confident, the closer and closer and closer to the mean that we regress to. Okay? And then number 8, business owner had a goal to get an average length of time a customer stays in the store. Hello. Above 10 minutes. Is there evidence that this confidence interval, that his business has met this goal? So 10 minutes is inside of our confidence interval. Now remember, if we are going between 9.4 minutes, we're going between 9.4 and 13.6 with an 80% confidence interval, and he says, hey, we want to make sure people are spending 10 minutes or more in the store. We do not hit this because this is here, okay? Remember, this is on a normal curve where basically we're going 9.4 to 13.6. It doesn't matter how close to this that we are. If it's in our confidence interval, it's hitting it. So we have to accept it. So being that 10 minutes is within the 9.4, or 10 minutes is within the 9.4 to 13.6, he's not hitting his thing because you're not counting the 0.6 of a minute at the lower end. Hey, good to see you, brother.
You too.
We're on page 81. And then backside. The Surgeon General set a goal that less than 15% of all Americans would smoke. A 99% confidence interval was created from a random sample. From 15.7% to 19.2% would be smokers in this case. Find the point estimate and explain the median context. So the point estimate is halfway in between. So basically, if you had 15.7 and 1.75, if we add 15.7 and 19.2 or subtract them, divide them in half, that means that we're going above and below a certain number of 1.75. So halfway in between that would be 17.45. That we feel that would be our parameter or our mean that we're revolving around. Find the margin of error, explain what it means in the context. So we're confident between 1.7 plus or minus 1.75. So, between 15.7 and 19.2 is where, between 15.7 and 19.7 or 19.2 is where we would feel that Americans fall as far as the addiction of smoking. Number 11, interpreted confidence interval above in context. So we're 99% confident that if we continued to do another survey of Americans, they would fall right around 17.45 plus or minus 1.75. And is there evidence in this confidence interval that the Surgeon General's goal has been met? Explain. Okay, so the 15% is within our parameter of 15.7 and 19.2. So he can't say that the 15% is below the 15.7% to 19.2%. So he has not met his goal. Okay, it's 1% likely that he would fall outside of that with his number, which is unlikely. I mean, there's a chance, but it's unlikely. And then a local real estate office, I think this is data from a long time ago, but they randomly select 100 homes to determine the average property value within the city of Denver. Resulting 95% confidence interval would be his point estimate of 440,000 with margin of error of 30,000. So a confidence interval, I would go from 410 to 470, subtract 30,000, and add 30,000 to the 440,000. Interpret this interval. We are 95% confident that if we were to select another 100 homes, that we would fall, our mean of those would fall between 410 and 470. So there's 5% chance it happens outside. Again, this must have been data from like 2005 or something. Name a way the researcher could have concluded that a study would have resulted in a smaller margin of error. If he lowers his confidence interval from 95% to say 90% or 80%, it becomes a smaller margin of error. And then a writer claims that the average sale price is $425,000. Is there evidence on this confidence interval? So $425,000 is within the $410,000 to $470,000. So yes, we have evidence that this does indeed take place. Questions for me? Are we good? All right. Oh man, come on, pop. I can't get it. All right. I'm now going to be on page 17, and we're going to be using some Desmos with this. Page 17. I don't know why I said page 75. I gotta blow my nose first. All right. We are doing something called a one mean Z interval, which means this. We have our normal curve, And this, in between here, is our confidence interval. Between here and here. That's our confidence interval. Okay? So what we want to do is, if we're doing a one mean z variable, we're looking at this area or this area. Okay, so it's one-sided. Okay, does that make sense? So the standard error of this type of situation is going to be the standard deviation over the square root of the sample size. Once again, the Greek symbol sigma stands for population standard deviation. We must know the population standard deviation to create this confidence interval. So the point estimate is simply the sample mean. Okay, so right whatever in between our confidence interval is our sample mean. The margin of error, or MOE. So the margin of error, MOE, is that okay, Ryan?
Yeah.
Margin of error is Z times the standard deviation over the sample size. Okay, so we have to figure out how do we get to this, and honestly, we're going to use Desmos in this situation. Okay, now I'm going to use a term. I want you to write this term somewhere down on there. We need to do something called halfway to 100. Halfway to 100. Somehow put that somewhere on your page, on page 17, that you would refer to it. And I'm going to talk about what this means in a moment. Okay? All right. So if I want to find my margin of error in the problem that's given, it says a company develops a test of leadership skills. This test is given to 50 applicants for a job. The average of these test scores 84. Assume the developers know that the standard deviation for all these tests is 12. Create a 90% confidence interval to capture the average score. Okay, so the big thing here is we are doing a 90% confidence interval, CI. Okay, what was the term I asked you just to write down? What was the term I asked you to write down? Halfway to 100. Okay, what is halfway to 100 from 90? 5, so it's going to be 95. So halfway to 100 means I'm going to use 95%, which is the same thing as 0.95. Okay, that's where the halfway to the 100 is going to come in. So if it's 80% confidence interval, halfway to 100 is 80. If you're at 99 for a confidence interval, halfway to 100 is 99.5. Does that make sense how I'm using that terminology? Okay, so the halfway to 100 is just kind of a simple way to think how we're going to make Desmos work for us on this. So I'm going to jump on Desmos because I love Desmos. If you love it so much, why don't you marry it, Mr. Stirrup? All right.
You can't marry an inanimate object.
True.
Or website.
Oh my gosh. My friends. Oh my gosh. Oh my gosh. Guys, I cannot believe I just did this.
What did you do?
I was teaching tomorrow's lesson. Today's is very much the same. All right, so go to page 15. I'm so sorry. You'll be all right. All right. So this is the one proportion Z interval. This is on page 15. I'm so sorry. Oh my gosh, I cannot believe I did this. They told me they were regular gummy bears. All right. So let me just see. This is pretty much the same. Hey, you're in luck. I had to start my lesson over because I was teaching the wrong day.
Oh, awesome.
So I'm on page 15. All right. So I'm sorry. We have the halfway to 100 still is going to play in. We're on page 15. All right. So Ryan, what is MOE?
Middle of error.
Margin of error. Okay. The only difference about this is we're going to be dealing with percents. So this one says margin of error is a way of estimating a likely maximum minimum population parameter. In this case, the actual amount of support. For Jones population, this was candidate Jones has a 54% support and has a margin of error plus or minus 4%. So they're saying that this candidate is leading the polls 54% with a plus or minus 4%. So that basically means between 50% and 58% is where we're going. Okay. The idea that Jones, so hey, there's something that we have to modify on here because there was an error. So 1, 2, 3, 4. So fourth paragraph down, see where it says 51 and 57%? Please change that to this. Where it says 51 to 57, change it to 50 and 58. It was a typo. Okay? The singular estimate, 54%, is the point estimate. The estimate is the best estimate we have on the population parameter. In other words, if we had to name a single percentage as our best guess, the actual support for candidate Jones enjoys would be 54%. The idea candidate Jones enjoys anywhere from, and you got to change the 51 to 57 to 50 to 58. Okay, there's two typos we did here. Was called the interval estimate or confidence interval. The estimate in many ways is more powerful point of estimate. If candidate Jones wants evidence that this level of support was over 50%, the interval estimate provides this. After all, the entire thing. So if he feels he's at 50%, that's the lowest of our confidence interval. Okay? So then if we're going to find the margin of error, we're going to use this. The P in this case, P is going to be equal to 0.54, and the reason I get that is because 54%. Okay, so if I want to figure out the margin of error, I have the z-score that we're still worried about, and we're going to get to that in a minute. So I'm going to go 0.54, and then 1 minus 0.54, all divided by our sample size, and our sample size, I believe, was... I don't know where my sample size was. I don't have a sample size given yet. I don't see a sample size. Anyone see a sample size here? So I don't know what my sample size is at this point. All right. So first question is, what is Z? Z is easy to find if you're 1 standard deviation or 2 standard deviations or 3, because that falls into the 68, 95, 99, 7 rule. So if we wish to capture 68% of the bell curve, we need to move 1 standard deviation away from the mean in both directions. So the z-score in this case would be 1. If we wanted it to be 95%, 95 is 2 standard deviations, so our z-score would be 2. But the shortcut that we're going to look for the margin of error is inverse norm halfway to 100. And this is how we're going to do on the back of page 16. This is how Desmos is going to work. We're going to do normal dist. Now, I've realized this morning. If you just have parentheses blank, it automatically defaults with the 0 and 1, which is fine. Okay? And then I'm going to put a period after this. I can put a 0 and 1 in here if I don't know these. This can be blank as well, and it's still going to work. Okay? And then we're going to go inverse CDF. And then this would be the halfway to 100. Okay? All right, so how we're going to do this is this. Our person said in example 1 on page 16, we have a sample of 60. Okay? We know in our sample that we have 75% support this. So 75% is 0.75. So let's find our margin of error. So we're going to have to, we have to figure out what Z is. We don't know what that is yet, but I'm going to do this. I'm going to go 0.75, 1 minus 0.75, divided by our sample size of 60. And that's going to find us what's underneath there. But now we have to find Z. And this is how we're going to find Z. Okay? All right. All right. Margin of error is 90%. What's halfway to 100 at 90%? 95. Okay? 95 is the same thing as 0.95. So this is how we're going to work it on Desmos. Okay? So I'm going to go normal distribution. Parentheses. So this is going to find our normal distribution. Notice I left it blank. This still falls into the 0 and the 1. Okay? If I plug 0 and 1, 0 comma 1, and it's still going to work, but I don't have to do it. But then after this, I'm going to put a period. And then I'm going to go under functions. I'm going to go down to distributions. And I'm going to look for inverse CDF. Inverse CDF. If I was at a 90% confidence interval, halfway to 100 is 95%. 95% as a decimal is 0.95. So that right there is my Z-score, 1.64. Okay? So if I take that 1.64, or 1.64, that should be enough. 1.64 times, and I need to make a fraction out of this. I'm going to go square root. And I'm going to put this in parentheses because I'm going to make this a fraction. So I'm going to go 0.75 times 1 minus 0.75 is 0.25. Okay, do you agree? And then divided by our sample size, which is 60. And so notice a few things. Okay, they come up with roughly 0.092. And there's another error that he has in there. So the error down there halfway, he says 9.9%. It should be 9.2%. Okay? There's all kinds of errors on this page. I'll tell you, it can't take us anywhere. All right, so we're going to say 9.2%. So if we go and we figure this out, we talked about 75% of the people support this, plus or minus the 9.2. So our interval is going to be 75 plus 9.2. So 0.2, that's 4, carry that, 84. So it goes from 84.2 for our top end. And then our bottom end is going to be 75 minus 9.2. So make that a decimal. That's not going to be an 8. That becomes a 4. That becomes a 6. That's 14. So 65.8. So 65.8 to 84.2%. That's our margin of error in this particular case of the random sample of 60 people that shows that 75% support cutting property taxes. We wish to estimate the true percentage of all people who support cutting property taxes. So it falls in between those two. So that's what we got. So what we could say is we are 90% confident that between, what was that? 65.8 to 84.2%. Support cutting taxes. Okay? All right. So the last one I want to do is example 2. It says a random sample of 200 Cherry Creek High School students, hey, they're talking about us, is conducted. 36 of the students plan to attend the next theater event. We wish to estimate the true percentage of this. Okay. So first thing we have to find is 36 out of 200 as a percent. That's 18 out of 100. Which is 18%, which is 0.8 or 0.18. Okay, so if we have a margin of error at a 99% confidence interval, 99% halfway to 100 is what? 99% halfway to 100 is what? 99.5. Okay, which is 0.995. All right, so we know this, that we have to go our z-score, which you have to find, times p, 1 minus p over n. So we're talking about the percent. So I don't know what z is yet, but my percent is going to be 0.18, and then 1 minus 0.18. Over n, our sample, 36. What's that? So let's figure out our z-score times this. That's going to give us our confidence interval. All right, so going back to Desmos, I'm going to change my inverse CDF to 995, right? So 995. All right, so I'm going to change this from 1.64, which I had last time, to 2.58. And then I'm going to change up here. We dealt with 0.12. Bless you. And then 1 minus 0.12 is 0.88. And then we have a sample size of 36. So round is at 14%, 0.1397. We'll round up to 0.14. 0.14 is 14%. Okay, so plus or minus 14%. So we think the 36 out of the 200 came to 18%. So I'm going to add to get my confidence interval. So I'm going to go 4%. So 18 minus 14 to 18 plus 14 is 32%. So this means that we are 99% confident that 4% to 32% of students will attend. Will attend. Attend theater. Theater. Okay? So the big thing that we're changing on this is make sure you know that it's normal dist. You can keep this blank. And that's going to still suffice as the 0 to 1 because we didn't know that. Period. And then inverse CDF. And this is going to be the halfway to 100. All right. Whew, I'll tell you, I'm sorry I started teaching you guys the wrong lesson. Now you got a precursor tomorrow. That should engage some excitement for tomorrow. So, for tomorrow, We are going to take a look at page 83, 84. Give it a shot. If you're here, I'll make sure you get the points for it. That's all I